Okay, welcome back, Physics 30s, to our next lesson in Chapter 3. This is 3.4, and today we're going to be talking about motors and generators. Okay, so from the previous videos, we've looked at the third hand rule, which tells us that if you have electricity or flowing charge, we can get a force. For example, if I was in a magnetic field like this, with south at the top and north at the bottom, we could put the field lines like this going north to south, and if an electron was coming out of the page, you can see it getting bigger here and coming out of the page, there's going to be a force. We could also indicate this with this sign showing the electrons coming out of the page. And we use our third hand rule to say if it's coming out of the page and our field lines are going up, then there should be a force pushing it in that direction. Now this is really useful because now we can use electricity not for just turning on light switches, but it can now move things and spin things and do work for us. Introducing the electric motor. This is a very simple diagram of an electric motor where we have what's called an armature in the middle there, where a wire goes up in a loop and comes back down. And it's going to be rotating or spinning in a magnet. So let's start with the field lines going from north to south. And we're going to run a current through this armature with the electron moving in this direction. Now again, when we have that moving electron in the magnetic field, we should get a force on this armature. So if the electrons are going up in that direction, we can use our third hand rule to show electrons, field strength, and force coming out of the page, which I'll show with this yellow line, or again, we could put the symbol like this with a circle showing it coming out of the page. Now on the opposite side, the opposite thing is going to be happening. It's going to be going down. Let's remind ourselves of the movement of that electron. It's going up on the left, but down on the right. So I'm going to put an arrow there to show down on the right. And again, we'll use our third hand rule. The electrons are now going down, field lines in the same direction, and we get a force into the page. So I'll put that with an arrow like this, or again with an X showing going into the page. Now with this motion, it's going to be pulling and pushing like that. We're going to get circular motion and spinning of this armature. So this is a bit of a simplification, but imagine that this is the negative end and this is the positive terminal of the battery. And I'm going to imagine that this wonderful prop is going to be my armature. When this blue end of the armature is on the negative, electrons will be flowing up this side, and they will be flowing down this side towards the positive. If my field lines are running this direction and the electrons are running up, this side will feel a force towards us. And if the field lines are again going in this direction, but the negative charge is going down, this will feel a force away. This will cause the armature to rotate in this direction. Now the armature would stop in this middle position, but then notice that this end is going to continue and now land on the positive side. This is going to switch it so now that our blue end is going down and the other end of the armature is now going up. Now we have the same electron flow up here, causing a force in this direction, and electron flow down here, causing a force in that direction. This will keep the armature continuing to spin. This is called a split ring commutator, and it looks a little bit like this. It's made of a conductor, and it attaches to both sides of that armature. And so I'm going to just kind of call the left side the green side here, and the right side the red. And when the electrons are pumped into this brush, then it goes through the split ring commutator and up into the green side. And then it's going to be flowing out of the red side. And so again, we see a force up and a force into the page, and we get the rotation. But as we saw with that demonstration, once it reaches the middle, that green side has moved over to the left. And before where that one was being pulled, now it's going to be being pushed because that was our negative end before, but now it's attached to this side of the battery, and now it's the positive end. So the current goes through different sides of the armature as it's going to spin. Now this is super useful that we can use electricity to create motion. But Michael Faraday thought, what if we could do the opposite? What if we could take motion and create electricity? And we can. This is basically running a motor in reverse, and it's called a generator. Let's think of it like this setup here, where we have a circuit with this metal conductor that will allow electricity to flow through it, but it's also free to move back and forth. Let's say we hook up a battery that runs the current in this direction. That's going to cause that electron to move down. Now, because it's moving in a magnetic field, it will feel a force. You can use your third hand rule in this direction, and that metal should slide. That's kind of the idea of a motor. But now let's reverse it where we move the conductor and see what happens to the electrons. So now I've replaced the battery with a light bulb. There's no power source here, but I'm going to push that gray conductor to this side, and when it moves, then the electron is moving in a magnetic field. We use our third hand rule again, and the electrons are going to be forced upwards to the top. That moving electrons in the circuit is going to complete a loop, and we're going to be powering that light bulb by moving that conductor back and forth. Now, back and forth would create the electron to go up and down, but that would be creating alternating current, which we'll talk more about later. This can also be applied to this diagram, but now instead of being powered by a battery, let's replace that with a voltmeter and see if we can generate some power. So it's not going to spin on its own, but if we crank this or spin the armature on our own, then we should be able to get some current. So I have flipped the magnet here, so the field lines are going from north to south. South is on the left, and if we use our left hand rule here by spinning the armature in this direction, the third left-hand rule, then if the left side is coming up and the right side is going down, we should get the electrons having a force up on the left and down on the right. So it's really similar to the motor, but to get that same direction of current, I've had to flip the magnetic field. And now I should get the electron flowing through, and I should get a measurement in the voltage. So that's it for this video, understanding how generators and motors are related and how they both relate to the third hand rule. This will be a lot of theory questions in your practice questions related to what direction things will spin, direction of current, and questions like that. So I hope this has helped your understanding. For you to try those practice questions, make sure you do give them a try, and I'll see you in the next video.